This is not about food, I'm afraid, but the food terminology does repeat multiple times in this code base, which is something I'm really happy about, seeing as I do love food. So Meze is a project I've been working on throughout gold cards, weekends, flights to the US. And I know that quite a few have heard the name mentioned because I've talked about it mostly in Gold Card Catch-Up. But I figured it was time that I actually told you guys what it is and what the idea behind it is. I'm not going into technical implementation in this one, that's why it's just a preface. But I'm mainly explaining why on earth I've been spending my time doing this and what I think it's good for. So I'll start with the three Y's. So what is Meze? Three W's. So what is Meze, why, and how? The W's right over there. So the first one is, what is it? So it's a library for implementation of composable components in order to declaratively construct JavaScript objects and primitives. Specifically, the idea is this. So do you remember that I gave a talk about 6 months ago? I'm guessing about half of you were there, about components and composability of components and what I think it's good for. So I wanted to build something that would allow me to do that, to build JavaScript objects and primitives. But why? So remember when we spoke? Yeah, just said that. So that was, like I said, 6 months ago. Half of you weren't there, half of you were there and don't remember a thing of what I talked about there. So thank God for the Internet Archive Wayback Machine. Not really, because it was a slideshow, but I brought back some slides from the presentation that I gave 6 months ago, just to sort of remind you what I was talking about. So I was talking about the fact that for a while I've been basically trying to find different ways to write code in a clean way, architect systems in such a way that I won't have the same maintainability problems and difficulty of applying change that I kept experiencing. So there were a lot of things I was trying to do, like breaking down my architecture to in object-oriented design with different layers, that each layer has its own concerns, and that wasn't really working, because while I was trying to build something like that, I'd always end up here every time, over and over and over again. And this happened, like, I thought at first it was me, but as I was moving between lots of different companies, it seemed like everyone was making this same mistake over and over and over again. So I went on a whole journey trying to figure out ways to avoid reaching this, which is one of the things that I was talking about in the last talk, and I won't go over it again. But the bottom line that I kept finding was that the core of the problem was high efferent coupling and fragmented state. Basically, a lot of different things were concerned with a lot of things that they shouldn't be. A lot of the code ended up being dependent on a lot of other code. It was very difficult to write things that were very independent and then put them together in such a way that would actually achieve something real. And the biggest problem was this, like the fact that just state was strewn everywhere. You had lots of instances and lots of things, and each instance had state that it had to manage and I had to be aware of, and if I was building a system, I had to reconcile between state in lots of different places, and that was often, constantly, again and again, causing problems. And we touched on, there's this thing, the favor object composition over class inheritance, and we've all heard about it, and it's in the Gang of Four book, and blah, blah, blah. And everyone tells us it's so great, but no one can actually tell us how to do it. Like, it's a very nice idea, but when it actually comes down to it, people say, oh yeah, you take this function and that function, compose them to a bigger function. But I'm trying to build an exchange. Like, that's much more than a function. So how do I apply these concepts in something bigger? I'll also remind you of something that I said in my last talk, which I put the date here on purpose. This book, which is sort of considered a tome, a Bible of how we should do things, was written in '94, which is like, sorry? When I checked it said 94, but I might have been wrong by a year.
It says 23 years ago.
Oh, yes. So that's not long ago. It's, I think, more for some of you than it is for me, but it's not that long ago. And my point was that we're really still trying to figure out how to make this kind of thing work. And it's a very, like, design in general is new, and software design is really new, and the concepts of how we build these kinds of things and how they operate and how is the best way for us to approach building these things, we're still figuring it out. So it's perfectly okay to look at something that everyone's been doing for lots and lots and lots of years, like 6, 7 years, right? And change it. It's okay to change ideas, because we wouldn't be where we are without changing ideas that came before, and we can still look at things that seem obvious and say, oh, maybe we're not doing them quite right, which is an important thing that I wanted to take away with you. But when I was asking myself, okay, so what is object composition? I have functions, they compose with other functions to create a third function, but what do I do when I talk about objects? Because when I'm building something big and complex like an exchange, or whatever it is, then we're no longer talking just about functions, right? We're talking about a much more complex entity. So when we talk about functional composition, we have function G, function F, and we compose them together to create function H, which is actually essentially sort of this mapping of I take all the parameters for the first argument, for the arguments for the first function, it gets passed to that first function, which the result of which gets passed to the second function, and that's returned, right? So this is functional composition. We've seen this before. And I was sort of like trying to map this conceptually to an object. So again, I'll speed through this. Basically, I assigned concepts to this is a parent, this is a child. There are arguments, there are the arguments that get passed to the child. How do I then translate those to an object? So I discussed this idea of a component function that essentially takes a parent, takes a child, takes a list of arguments which correlate to the arguments here, and a list of children, and each one of those children is yet again an instance of what's returned by this component function that essentially is the same thing. And the composition is actually taking this and applying it here. I explained it much slower and clearer last time, but there's a bunch of things I'm trying to get through. So conceptually, just imagine this theoretical component function, this pattern that allows me to connect more complex pieces together while maintaining a very clear API for how they get composed together. The key really is that function composition is very easy. You have input, which is the argument, you have output, which is the return value, and that's the contract between them, so it's very easy to connect them together. Objects are much harder because it's different APIs, different methods, different ideas of how they talk to each other. The idea of a component function is to say, okay, even the API of how these pieces talk to each other, I'm standardizing that. And you can't deviate from it, but it's still rich enough to allow you to do really complex concepts. So to answer the actual question of why, we have a bunch of implementations that implement this component function. The first one that became popular was React. React gave us this exact API for composing components meant for creating UI, and that's triggered a bunch of follow-up implementation. Polymer is slightly different because it's a general web component architecture, but in the concept of how the pieces sort of fit together, it's very reminiscent of this same sort of API, not necessarily the identical API. Component kit is exactly the same, it's just for iOS. Bless is the same, but for, or React Bless, which is an implementation for Bless, is the same for building terminal-based apps. So you get the same API that React gives you, but for building UI for apps. Inferno is like React, it's for building DOM in the browser, it's just designed in a slightly different way, meant to be much more efficient, and actually the developer who created that recently joined the React core team. So hopefully we'll see ideas being translated from Inferno into React. But there was no implementation for doing the kind of thing that I wanted to do, which was I wanted to build a back-end system that was essentially a piecing together of operations and computations resulting in data that I then give to something else. So for example, if we're talking about the exchange, we're talking about an add call to the exchange that gets translated into bid request, that gets sent to a bidder, that results in a bid response, that results in hopefully an ad response, which we would pass somewhere. So that kind of process, I wanted to be able to take the same component composition that I got from React with the same design patterns, the same concepts like higher order components, things like that, but to build things which are much richer than a UI, or not richer, but completely different conceptually. And that didn't exist, and I wanted to play around with it. It was essentially a thought experiment. It was like, if I were to build that kind of thing, but with the API that components gave me in React, what would that look like? would that even work? Would that make any sense? And I figured I wouldn't be able to tell if it made any sense until I actually built it. So I did. I basically said I want to build complex processes and systems on the server side using component composition. And why JavaScript? Because I like JavaScript. And it's the language that I know best. So I figured the language that would make the most sense for me to try and implement this in would be JavaScript. And hence I did it that way. No, mouse! Screwed me. Okay, so 3 things when it comes to the how question are what is the difference between this and React? Like why is this different at all? Why can't I just use React to do this? Another thing I mentioned in the talk last time was that React actually is a bunch of different modules, libraries. One of them is the React core, which is what actually includes the component composition concept, and React DOM, which creates the DOM tree out of the tree of components. So, so in theory, I could maybe use React core for this kind of thing. The answer is no, and I'll explain why in a second. Second is, okay, so React builds a component tree. What is the equivalent in Meze? And what kind of API did I actually build in the end? So, first of all, difference-wise, React is a library for building user interfaces. It essentially constructs a tree of components which it then updates in various ways. It's about the flow of state and data through this tree, as opposed to what I'm trying to build, which is essentially one operation that results in data. It's not a long-lived tree of components. It's a tree of components that perform a set of operations and computations in order to result in a final thing that we can do something with. So, yeah, just sort of repeating what I said a minute ago, which is React comes with React DOM that helps you build a DOM tree. Meze is something really different because it creates a component tree which expands from the root, doing a set of operations, and then reduces back into a single primitive or JSON object. So if we compare the actual component tree, how does it work? So in React, we have a component tree built by the implementation of React with the components that the developer has put together. And then there are sets of operations that cause state to change using the set state operation, which then marks various leaves within the tree as dirty, and then it re-renders based on the dirty nodes in the tree. Meze is something completely different. So though the API is the same or similar, anything that happens under the hood is going to be completely different. Because in Meze, the concept is this: I build a tree. Damn it! I hate this mouse. It's really screwing in my slideshow. There we go. I build a tree, which basically expands from the root as components get mounted into the tree and slowly builds up an entire tree of components. When it reaches the end, it's going to start the reverse operation, which is it'll start contracting in each component, taking its children, resulting in a value that goes all the way back down to the root, and you get your final result. Sounds very simple to do, right? When I started doing this, I was like, oh, I'll get this done in like a weekend, right? I'll just quickly copy the API that React does, and then it's just like build an object, reduce. What's the problem? So not quite. It's actually much more complicated than I thought. For one thing, processes aren't a linear thing. Yeah, if all I wanted to do was build a simple JavaScript object, yeah, not hard, quite simple. But I wanted to do something much richer than that because I want operations. They might be asynchronous. There might be an API call that needs to be made. There might be I/O. Both of those are I/O. There might be some kind of timely operation that I can't just synchronously reduce into a value. Branches of components might end up having various side effects, things that don't necessarily return a value, but you also need to provide the developer a comfortable way to use this and model this, because otherwise this is not going to be of any use to anyone. DOM makes a lot of sense as a tree, because that's what the DOM actually is. It's a tree of elements. Data and process don't really model that way, so it was very hard for me to figure out exactly how to present this. I did a lot of hacking together of ideas. I have like a Meze junk repo, or it's called something else because it wasn't named Meze at the time, but the point is lots of different ideas of how a developer might use this, and it took me quite a while to figure out what made sense as a developer. And also there's the concept of composition types. So in React, every component returns a React element. It results in something that represents DOM or a wrapper of DOM. And so it's like a tree of the same type. But what I'm dealing with is reduction, and a tree that builds out into reductions of lots of different types. It could be primitives, it could be objects, complex objects, it could be promises, it could be a lot of different things. And figuring out how to model the composition type of a component and how to add things like validation to make sure that you're not accidentally returning something different than what you intended to return, which is one of the really nice things about React. It gives you very nice property validation, that kind of thing. So figuring that out was also quite complex. And as far as the API is concerned, I wanted it to be as close to React as possible. Not because React is necessarily the best thing, but because it's a model that people already know. If a React developer wants to start using the same concepts that they have gotten used to using in the UI, the things they're used to using in the UI, if they want to start using this in the backend using Meze, I want that transition to be as easy and as clean as possible. I want to make it easier for developers to try this, not harder. So I wanted to try and build the exact same API and come as close as possible. And I think I've come very close. And to achieve that, there were a few things that I wanted to adopt from React and take with me. So the first one was JSX. JSX makes perfect sense with DOM because it's like a mapping of, oh, this was what it looked like in HTML, now I'll do it in React components. It made a lot of sense. Here it makes a little less sense because of the concepts, but again, because people have already gotten used to thinking of these not as HTML DOM elements, but rather as pieces of composing logical pieces that might result in DOM, that might just be a logical operation. I don't think it's actually that hard to make the transition. I've been doing it quite a bit, sort of like pulling away from Meze for a while, coming back and just playing around with the JSX implementation, and it works, but you never really know until other people try it. The concept of stateless components, in React we have stateful and stateless components. This makes no sense as stateful because it's not a long-lived tree, it's an operation that results in a value, so there's absolutely no reason to add the complexity of state. State flows in and then reduces back. There's no long-lived state, so everything is a stateless component. Properties, props and children, same as React, I've taken along with me. Prop types, as in you can do validations on React components, making sure that the props are the same types you intended and the context and things like that, so that's come along as well. And I'm trying to create as many easily readable and informative error messages and warnings, just like React. As far as the actual implementation is concerned under the hood, I won't go into the JS details, but just the top level API. So we have a compose function, which is a root composer. Essentially, you build a tree of components, pass it to compose, and it will compose the result for you. It's exactly the same as React.render, which takes a tree of components and renders them into an element. Component is the factory that essentially takes a function and gives you a component. Create component is like create element in React. It's a thing that essentially mounts, it takes a component, creates an instance of it, and passes it along to the tree to be mounted. The component instance is the thing that's created by create component. And children is data structure that represents the children of a component. It's the same concept as in React, except that because of the kind of things you need to do with data relative to elements, it's a much richer data structure than the one provided by React. The data structure is simple, but there's a nice API around it, so you can do a lot of more complex things with it. Whoops. And I've also added a couple of modules along with Meze core, which is, first one is Banquet, so you can see the theme of food here. Banquet is just taken Meze, wrapped the Restify library with it to make it easier for developers to start building HTTP endpoints from Meze and all the way down. It's ready. Anyone can just do npm install Meze and Banquet and start building an API endpoint using both of these. I've built a set of Babel plugins to transpile everything. And test utils is a bunch of utilities to help you do unit testing, because again, as people who highly believe in TDD, I wanted to make sure that anyone who adopts Meze can start writing tests immediately. And validation of types for props, context, and composition. Composition is the result of a component tree, or of any component. So conceptually, how do you actually work with this API? Let's say I have a function, takes props, returns a panda. So I'll take this function, I will pass it to component to create a component, I'll pass it to create component in order to create an instance of the component, and I'll pass it to compose in order to compose this function, which would result in a resolved promise with a panda in it. Simple, right? I mean, there's only 3 functions you actually need to call. So kind of cumbersome. So thanks to Babel, you could just use JSX, create a component of f, pass to compose, and you get your promise resolved with a panda. So exactly the same kind of thing as React. The difference is my components are much richer. They're not just returning elements that are creating DOM, they are for data and operations and various things like that. So they can return a number, a string, a boolean, an object, a function, promise that will do something, other components, of course. You can compose components within your component and return them exactly the same as React. So you have the same richness of this connects to this in the same way that this connects to any other component, which means that I can basically put everything together easily without having to create an API between them. The API is already there. It's promised to me by the Meze global API. It's exactly the same thing that people are enjoying so much about building React components. They know that anything can be connected with anything easily, which means they can be moved around, which means they can be replaced with arguments. I don't know who the children are because whoever uses my component will compose me together with whatever they want. It's not up to me, but I can refer to those children and re-render them and, recompose them and pass props down to them and events down to them and whatever I want. I have the same richness of composability that React gives people when they're building UI. So exactly the same ideas we were talking about when we were talking about React, the richness of components that contain components, like containers, higher order components, the typing that you can get on your props and on your context and on your return values from a component. You get all of them out of the box. I'm running out of time, so I'll just point out there was a list of things that I said conceptually this theoretical component library would have to implement in order to provide you with composability. So my library implements all of them. Which was the goal, so I'm pretty pleased with the result. Very, very quickly, just a piece of code. So I import Meze, import some pieces from Banquet, which is the REST wrapper. Then I can create functions that return values and do completely atomic operations. This is returning a string, this is returning it's performing a fetch to an API endpoint, which means it results in a promise. And when that promise comes back, I compose it with another instance of this component and return it. And down here, what I'm doing is creating a server, composing it with methods, get methods, composing them with responses to just send it back, and composing that with these functions. So there's my server, I do server listen, and it's running. And then I can just ping it's Nagios. I can clone my endpoint and start getting pandas back and all good and well. Last slide, I promise. So why am I spending my gold cards on this? I've spent maybe 90% of my gold cards in the last 4 or 5 months on this project. And that doesn't actually say much because I haven't had that many gold cards with my strand, but it's a lot of time. So what have I actually achieved from this? Why was it worth investing my time into this? So first of all, it's fun trying to figure out these kinds of really complex abstractions, how you can make it a nice, usable API and how to actually make it work under the hood. It wasn't simple at all. There's more test code than there is actual code, but it works, and that was a real fun thing to figure out. I've learned a shitload of libraries to make this work. First of all, it's typed, it's with flow type. Using Lerna to manage multiple modules and have them talk to each other easily in the dev environment, and Babel plugins to actually make it work. I've been digging very deeply into the React codebase, Enzyme, Inferno, a bunch of other code bases to figure out how to make these things work and how other people have implemented them. So learned a lot from digging into their code. I'm looking at the way that I think of operations and computations in a very, very different way than I used to. So I found that the JS that I'm writing and the Java that I've been writing has actually changed because of challenging the way I think about code in this project. And also, so Meze is built really, really deeply on a lot of concepts of how promises can be used when you're actually building your code. So I'm not talking about the promises that users will see when they use the library as much as how I've used them in the implementation. And it's completely changed my understanding of promises and what they are and what they're about. And I've actually applied to speak in a conference later this year about this. Hopefully I get selected. So I've sort of achieved like a promise zen. I see them completely differently than I did before I wrote this project. So that was also very useful. It's on GitHub, it's available, I opened it a while ago. There is a warning, this is still very much a work in progress, but a bunch of friends of mine have already started looking at it, playing around with it. I got a lot of feedback. I've written a lot of docs over the last few weeks. So in theory anyone can just start using it. In practice I don't think anyone's actually using it, but that's because no one knows that it's there. But it's real and it works, and I've been playing around with it, and I'm actually building a OpenRTB exchange using it now as an experiment. So we'll wait and see where that goes. This was the last slide, sorry. So where from here? I still have a few core features that I want to do. I want to improve the type checking, some better error messages. There's still some concepts of composition which are missing. For example, a component can return a promise, and I know what to do with that. If it returns an observable, I'm not quite sure. So I need to still add some core features for this. I also want to make it pluggable so that anyone using Meze can implement any kind of reconciliation logic that they want for any kind of specific type that they want to do. Additional testing features include documentation. I've talked about this before, that I perceive documentation as having empathy for any developer who is forced to use your library or chooses to use your library. So it's really important to me that I improve the documentation. And I'm already working on a proof of concept, specifically an OpenRTB exchange, not putting any of our business secrets in there. It's very much sticking to the OpenRTB spec, but it's a nice challenge to try and build that with the library. It's already raised some issues that I wasn't aware of, and releasing to the community. So like I said, quite a few people already know about it and have been giving me feedback, but I haven't posted it on Hacker News or anything like that until I get this really ironed out. I don't want it to go out too far. I think I've already taken up more than my 20 minutes, right? But
4 minutes of questions.
okay, cool. So questions, anyone? Andrea?
What happens if any of the components fail on the way?
It's so I didn't talk about it too deeply, but every component essentially results in a promise. So like any promise chain, if one of them fails, the whole chain fails as a promise catch. So compose, the root function, essentially returns a promise, which means that you can use .then to get the result, or .catch to get an error, and any component along the way can easily apply the same kind of thing to the composition that's inside of it. So I can easily say, oh, compose any children I've been composed with. I don't know what they are. The developer has put there whatever they want. But I want to catch any error that happens underneath here so I can deal with it. So because everything is essentially a chain of promises, it's very easy to do.
Yeah, so if you have you thought about using a single await, stuff like that? Does that change anything?
I'm using async await throughout the tests. For the implementation, less so, because async await is more about hiding the use of promises. It's about writing code that looks as if it's synchronous when in fact it isn't. That's not so relevant here, because the promises that I'm talking about here are how the pieces are connected together under the hood. The developer never sees that anyway. That's all internal implementation of how the tree is built and how it's reduced back in. It's less relevant for what the developer actually does. If a developer wants to use async await within, in theory, I think that any return within the await would end up just resulting in a promise. I need to see how that's actually transpiled. I'm not sure. But
like if you do async function component, then the whole thing needs to have asyncs all the way up for you to be able to use await on the whole.
yeah, that would be an interesting one. I need to look at what would happen if someone actually does that. So that's another thing to add to my to-do list. Bruce?
So, in functional programming, one of the things you try to do is to push side effects to the edge so that you have pure referentially transparent functions. And you said that one of the challenges you found with implementing Meze was that somewhere in the chain of compositions you may have side effects. So is there something analogous that...
Well, so it's mostly...
to the edge?
Yeah, so it's mostly about how do I build a library so that if a developer wants to do those side effects, despite all the evidence that that's a bad idea, I can actually provide that. I don't want a developer to go, oh, I really want to write, like, hit a metric to Graphite before I continue with the composition here. Is there a way for me to do that? And I'll go, no, you can't do it. Then no one will use the library. So it is possible. All you do is return a promise, and the chain will work as promised. But
So you took a position that you wouldn't try and enforce your view of pushing side effects.
oh no, this is JavaScript. This is not Haskell. No, we want to make it accessible and usable, not theoretical and academic. Sorry. Am I still allowed into Haskell Club on Fridays? Sorry, no, it's trying to be as open and flexible as possible. It's not a good idea to do those things too much, obviously, but as long as you return a promise, you can do whatever you want and resolve it whenever you're ready, and I'll take the return value you gave me and use it in the reduction. So I'll just wait for the promise, pretty much.
Cool.
That's that. Thank you very much.